morning. Thank you for inviting me to give the talk, and thanks all of you for coming in to listen to the talk. So I'm just feeling a little bit, with all the music and other things, this may be a little bit of anticlimax and too techy, but I hope you are here for that. So what I'm going to talk today, I just want to give you an idea. I would like to start by Story of Isambard AI, because this has happened in such an unusual way. I've been working in supercomputing field for about 20-some years. It doesn't happen like that. The UK government decided to super accelerate the AI research resource program through which Isambard AI is being built in record time. These things take years, and we are doing it in months. And that's why if I look a bit shaken, it's because of that. But the story didn't start with Isambard AI. The story started with Simon McIntosh-Smith, who was the PI of Isambard. He started investing and investigating using ARM processor, which is, again, a UK-based technology for HPC. Then I would really like to take you a little bit inside to see how it is designed and the core design principles for us for sustainability. Because once these computers are so powerful, but they use a lot of power and they generate a lot of heat. It is highly performant. It will be one of the fastest systems in the UK and probably around the world, around the world. And the thing that I really, really care about is accessibility. We really need to make these powerful devices available to everyone who likes to use it. And then if someone hears me, for me, the key measure of success, it will be powerful, it will be sustainable. But if users aren't happy and they can't use this productively, it is, in my view, is not as successful. So ease of access is a key part of the thing, and ease of usage in terms of acquiring resources in there. So you are all, maybe outside a very small group of people today, will know a lot more, hopefully when I finish my talk, what's inside Isambard AI. So the take-home message I would like, after 20 minutes of my talk you take, is how sustainable and why it is sustainable, why it is performant and how performant it is, which is really powerful, and what are the features that make it highly accessible. So what happened was, exactly a year ago in Birmingham, I think some of us, you may went to the conference, in March, the UK government announced that the UK is falling behind in terms of computing power for open research compared to peer nations and sites such as Europe and USA and Japan. So there is a link, or you can go and look at the Future of Compute report. It came out, and the photo is from there. So I'm not expecting everyone to read it, but what it gave us like a framework and a roadmap on how to approach designing an AI system. So compared to the exascale or exaflop in some cases called systems like, it was very clear that AI systems should be accessible to all users. You do not have to be very specialist to be using that. It should be sustainable, because once you start using GPUs, as I said, it gets a lot of power, a lot of computing, accessible to all sectors. And if you see in this picture, the traditional sector doing high-performance computing for decades and decades are really small. AI touches all of our lives. It should be performant, even if you use a small number of GPUs, or you'll use a very, very large number of GPUs for large-scale training. And most important of all, there is an AI-RR program in which we are working closely with Cambridge. So it is not about technology. It's really building what we call an ecosystem that includes people. Training the people is really part of it. So I would really like to show you a timeline until today, and it is changing now month by month. So as I said, from 2016 up to July, I think something probably, there was Isambard, an ARM-based, CPU-based system that Simon McIntosh started, which was a small investment. And the most important thing was there was no dedicated team working on it, which was part of GW4. And what you see down there is a car park at the National Composite Center in Bristol. That's where, by the way, Isambard AI is going. So there was no data center. It was hosted by the Met Office. In August, we received a feedback on the proposal we wrote for building Isambard AI. In fact, the third week of August, where they said, OK, we like your proposal. How can you quickly build it? So just to emphasize, over like 6 months ago, these things take year and year everywhere. And still, at that point, there was a car park in there. Isambard procurement also happened in like a real record time. And this happened preceding to, if you recall, there was an AI summit, really international, global, led by the prime minister. And this is the photo with all the dignitaries. It happened 1st and 2nd of November. In December, we started hiring a team, building, so you could imagine. And at that time in December, this picture didn't come out because it was a very cloudy day. Someone is digging up dirt inside the car park. So there was no data center. It was a platform that needs to be built. It turned purple. Did I do something wrong? Should I continue? OK. I thought I should do or say something. And we are in March. Our small team started already. So this is a training for the system. And up there, what you see, I will show a close-ups. Now the modular data center is there with chillers and other things. And next month, a whole lot will happen. So all of these things is happening in 3 months. So it, as Simon says, is almost impossible, but not quite. So just to kind of zoom in, so this is, again, as you can see, it's still a car park, and Isambard 2 will come separately. And down there, it was so scary because it was it's not scary, it was expected. It was a windy and cloudy day. So if you see, there are people holding on to it so it doesn't spin when it is placed down there. There is chiller and pumice kit, then go there. And then there are trenches for the NCC and MDC there. Oh, this completely messed up from, I think, AI. I will skip this slide because it should not look like that. So I think something kind of got a bit messed up in the thing. But what it was supposed to show is where is Isambard 2 and Isambard AI. So going back to the sustainability, the reason we chose modular data center, among other things, because these are highly sustainable, replaceable, recyclable. And they are designed according to specs, as opposed to when you can call it like a brick and mortar data center where you have to over-provision it for different things. So the first element is we set our optimization targets. So it's not just good enough to say it is sustainable, what you do about it. So we set our optimization target. This PUE is a very technical term, but the idea is anything 1.2 is considered pretty good. Industrial scale is 1.3. We are targeting less than 1.5. We are trying to use all non-fossil, and then there is a plan to reuse all the heat that is being generated. University of Bristol has set itself a target of net zero by 2030. So we, in the procurement and design, we took it to heart. And we look at it, each and every scope emission and how it could be optimized. So scope 1 is very little because there is a very small diesel power generator just for local running. The majority, 90%, is coming from the grid. And then the rest is like supply chain. It's difficult to measure, but you can see. So we will really make sure these are optimized. And at the end of the life of the machine, majority of the components will be recycled in the UK. Then going a level inside or outside, the system we chose is a direct liquid cooled system. Is it working? Yeah. And this is called HPEX solution. It's really densely packed. One rack is about 350 kilowatt. And it has enough power and cooling to run these very powerful GPUs. But including the GPU, if you remember, and if you think about it, people use the x86 with, and this was one of the questions people ask us, why are you using a new ARM CPU and this GPU? The reason was they were so tightly connected. And that tight connection allows us to save energy for doing these fast computation. Finally, what is Isambard AI for? Of course, I'm pretty sure you are all here doing some or most of it, training large language models, large-scale inference, foundational AI research, AI safety and understanding, hybrid AI and simulation workflows, and machine learning. And research on Isambard AI must have a very, very strong component, AI component in there. And as I said, we will accommodate jobs or user payload that can go from individual GPUs to almost 5,000 plus GPUs. Now, just going one level more deep, again, you saw this picture. So each single, unit of Isambard is in fact 4 Grace Hopper nodes. They are tightly connected with very fast links, and then they have very high bandwidth to each other. So 4 Grace CPUs, and if you are into technical things, it's like about 512 gigabytes of memory, 4 Hopper. Collectively, each single Isambard node has almost a terabyte, just under a terabyte of. So if you are doing a single model that fits in that memory, it will go super, super, super fast. But and the bandwidth is just out of this world. Not only that, when you build these large-scale systems, because you do not only want to be fast on a single node, but you want to be fast when you scale to thousands of GPUs, there is a massive injection bandwidth per node that you could use. This is really interesting. So I've been working with GPUs almost, it will show my age, 2006, 2007, maybe a bit earlier. They were really badly used. And one of the things we always wished importing and refactoring code was going over a PCIe bus to a small memory and orchestrating and managing this. This solves, the Grace Hopper chip solves this problem because they are both coming from NVIDIA, so they could optimize it. So just to give you an idea, I really call it a boon for developers and users, because I'm not suggesting anyone is going to do that. You could be really sloppy, but you still can get very good performance. In previous GPUs, that was not a given. And we have tested it for showing that. So if you look at the disjoint page table, which you typically get from an x86 to Hopper, you really have to be very careful about memory pages moving in and out. But in this case, there is a special technology which just completely hides it. So you can write your programs or use your program as is, and it will work very fast. Other thing I'm really excited about is this use of technology coming from Cray HP called Slingshot. It's been almost 3 years old, but that is the first time they tried combining the mainstream commodity Ethernet with high-performance computing technology. So, and taking the best of both systems. And it uses this topology for faster communication. The important thing I would like to highlight here is even the network is liquid-cooled for performance. So if you are on Isambard, then you ask, what do I expect? So if you come from a more high-performance computing background, you want to tune and optimize your program on close to the hardware, you will get familiar programming environment from HPE, like C, Fortran, other compilers and libraries. So it will not be new to you. But the most important one is, I think majority of the users will use some sort of NVIDIA stack at different level of abstraction. So the message I want to take you from here is each and every level of abstraction almost will be available to you, starting with using GPU, CPUs. Of course, the network is different. But from CUDA to the frameworks, Slurm and Kubernetes, so all these environments are going to be available for you. Our target is you can just grab a container from NVIDIA GPU Cloud and GC and run it on Isambard without changing anything. This is kind of really, really important thing for us. And I never thought about it. I'm a high-performance, a supercomputing person, so I always think about, as long as you are doing things fast, it's good. In this case, no. We know AI will do a lot of good, but we also know there are several risks that need to be considered. So we have been talking to different people, and we were explicitly talking to NVIDIA about it. I said, what are you doing? Because people are using your abstractions, your frameworks. Are you doing something about it? So last month we were in the US, so they introduced us. This is some of the work they are doing. And I can go into detail, I think, offline if anyone is interested. So they call it Nemo guardrails. And again, it's not like silver bullet. There is still a lot of work to be done. But the good thing is we are setting up collaboration with NVIDIA specifically to develop AI safety and trustworthiness, because this is the mission of the UK government to enable in open research, academic environment, this type of work that can feed back not only to understand the fundamental concept, but also to legislate and to protect us all in a way. We can't compete with big institutions with 25, 30,000 GPUs with 2 or 3 GPUs in academic and research environment. So it gives us a fighting chance for open research environment to do something about it. So I'm just copying here. I have not used it. I have just seen the parts of it. And this is some of the thing in teaching, training, and engaging with NVIDIA. We will work quite closely. I asked NVIDIA because I said, you have your GTC, can you send me new results? They haven't sent it to me, so these are old results. I think the footnote here is Grace Hopper is fast. So in the interest of time, I will just go back to the last few slides. So we design supercomputers, but these supercomputers, I call them digital research infrastructure or digital research instruments. So they are used for research, and people calibrate, tune, and use it over the lifetime. But they can only do it if a scientist or a researcher can easily use it. So one of the very first thing, and now we know people will come from STEM fields, but people will come from other parts of our societies and communities, like social sciences, and literature, and all these other areas. So we said, what can we do so they have a look and feel of not an HPC system where you go to the black screen and do SSH and things like that, but they just get like a normal browser or a cloud native type of feel. And for that, we are enabling in a secure way, single sign-on environment that is supported by UK Access Management Federation. And we are using multi-factor authentication for that part. And the other thing we are doing is providing a very much self-service type of environment, because we are expecting not only 100 users on this system, but thousands of users. And our team will be probably 20 to 25 people if completely scale out. So we need to build the system so it can scale without scaling a large number of people. And when you are there, not only you can access different resources, but you can also see how much I have used it and whether I have used it correctly. This is kind of really important in the sense of what do you see? So there will be a Jupyter Hub type of environment, but we will support Slurm and Kubernetes type of environment to support common usage pattern of AI, which are experimentation, training, and fine-tuning. And they have different usage behavior. And a few months ago, or maybe 6, 8 months ago, Google published an article about what they call AI hypercomputer. And we are going to try leveraging it, because what they have proposed is not that much new to our community, like supercomputing community. They say we will have a flex start mode for large jobs that will run for a long time. And in HPC, we do it all the time with checkpoint restart. Then they say there is a calendar mode. We don't do it in HPC community that often, but it can be done with reservation. And I would argue here that it is simpler for us in Isambard to implement that, because in Google, they have to make sure all these GPUs are closer in a public cloud region. We know all the 5,200 GPUs are connected with a high-performance network. So this is my last content slide. Isambard AI phase 1 is already here. So 168 Grace Hoppers are already in Bristol. And we are testing it inside the modular data. In fact, we are trying to plug power and other things right now. But not in too distant future, it will scale out. there are new systems that will come with a new data center, and it will have a lot of GPUs, a lot of AI-specific storage. And we are really working on the calendars. So this is, I'm finishing, because my time is up now, and I'm happy I pretty much stayed on time. So if you may recall, this declaration came out after the AI Safety Summit back in November 1st and 2nd. And while we are talking about technology or building this network, we are really trying to make sure we support the government initiative for enabling how we make our environment, not only to do things like enable AI, but also to do it in a way that is safe and secure for everyone. So stay tuned. A lot more will happen this year. Thank you.
Thank you, Sadaf. No, don't go anywhere. We are strictly out of time for this session, okay. But I just want to throw one question at you. One question that's come in from Keith, if Keith is here, saying, where would the user requirements come from, and how do they get fed into ongoing development for the Isambard AI vision? Is it a build it and they will come? So I know that's a huge question. I'm going to ask you to answer it very briefly so we can let people have their 10 minutes.
Yeah. So no, that is an excellent question. So I gave you very accelerated timeline. So the first set of user requirements when we went for procurement, it came from the Future of Compute report and some of the initial government paperwork that came around AI usage. As I said, how it will continue improving and evolving, I call it digital research instruments. So as people come and start tuning and calibrating it, these requirements will fed back, and the instrument will be tuned as it goes. So like an iterative process with users. Brilliant, fantastic. I'm sorry to cut this so short, but we are very keen to give you the 10 minutes, so if you want to move around, you can. So please thank Dr. Sadaf Alam for starting us off on this stage.